All right, how's it going, guys? I am going to quickly show you how to use the technology for this upcoming lab you have. It's the Gravitational Force Lab, the easiest lab you will do this year. How exciting. So you will be using this thing right here. It is a force and acceleration sensor. So what it does is it measures force and it also measures acceleration. So that's why it's named that way. We only care about the force today. We'll care about acceleration later, but we're keeping it simple. We're just going to focus on force, and we're actually going to specifically measure how much the gravitational force is on various amounts of mass. So gravity pulls on mass, and so if you have more mass, then that changes the amount of gravity that the Earth has to pull. And so there we go. We're going to find that relationship between the amount of mass that you hang, like this right here. See, this is a mass. You can hang it onto your force sensor. If you want to hang more mass, you can just take the hook down below, and then you do this, and you just measure more and more mass, and get a minimum of 5 different masses, so you get 5 different gravitational forces. And by the way, when we measure gravitational force, there's also another word for it. It's called weight. And so weight is how much the Earth's gravitational field is pulling on a mass. So we're trying to find that relationship of the weight versus the mass, or the gravitational force versus the mass. So here we go. This is the force sensor. So what we will be doing is we will be using a program called Graphical Analysis made by Vernier, same company that makes Logger Pro. That's why I put a message out. Hopefully you downloaded it. If you didn't, please do it as soon as you can. But this is how you will get to graphical analysis. And you will either go to the Launchpad and click on it there, or you can go to your Finder and go to Applications and go down to Vernier Graphical Analysis. So I'll just open it up that way. It doesn't really matter. So here we go. So it opens up and you have a screen. You can maximize that screen to take up your whole, or maximize the window to take up your whole screen. I am keeping it small so you can see my face as I talk about this. So you see there's 3 options, and each option you can choose for various reasons. But the option we care about today is sensor data collection. But before I go to that option, because this is the sensor that's collecting the data, I need to plug this in. This is a USB connection, and it can go right into the side of your computer. So this is actually a piece of technology we do not have to plug into a LabQuest like we did with the motion detectors. This goes right into your computer. But because it goes right into your computer, that means we have to use graphical analysis instead of Logger Pro. Oops, we've got a communication error. Let me say OK. Now let me click on sensor data collection, and in doing so, it changes the graph to force versus time. So if I wanted to collect force versus time, what I could do is I could collect, and I could pull the force sensor and get a nice big positive force, or I can push it and get a big negative force. Anytime you pull the force sensor, it's positive force. Anytime you push it, it's a negative force. And so all that is giving you is the direction of the force. That's negative and positive is just direction. All right, that's awesome. So let's try to open this up again. I'm keeping the force sensor plugged in. And all right, I'm going to go to my Launchpad and try to open it up. Hopefully it works. Maybe I need to update the program. All right, so I opened it back up and I have force versus time. I'm so glad that happened. Just in case it happens to you, you won't feel so bad, right? So I have this graph, but I don't really care about the graph. I only care about the number right there. And that number is 0.37 newtons. So right now this thing is measuring 0.37 newtons, and it shouldn't because we have nothing on it and nothing's pulling or pushing on it. So what I want to do with nothing on it is I want to click on this box and I want to go to 0. And now the sensor is zeroed, and you can see that it says 0, and it might go to 0.01 negative or positive. That's literally because of my air blowing on the hook. That's how sensitive it is. But I don't want the screen to be the way it is. I want to go up to this thing, and this thing allows me to either see 1 graph, 2 graphs, 3 graphs, a table, which is the data table, or a meter, which is just literally the number that this is reading, and then a graph table, which would mean a graph and a data table. Well, I care about the meter. I just want that nice and big, just so I can see it. And so now I can hang mass on it. So I'll hang this nice silvery mass on there, and the masses are stated on the piece of mass itself. And you'll notice that when I measure this, the number is fluctuating a little bit. So you're just going to want to find a number, the nearest hundredth, that you think it's in the middle there. So I don't know, maybe 1.95, maybe 1.94. I don't know. You're going to the hundredth. It's such a small amount of force. And so that's the force. It's a gravitational force measurement that's pulling on this mass. Cool, cool, cool. I had one more thing I wanted to say. I just lost it. Oh, a reminder. Remember, I just hung one mass and got one gravitational force. You want to do a minimum of 5. Now you'll have a tray of masses, so you can do just a different mass hanging on to it, or you can do what I showed earlier, is just put one mass on and then hang another below it, and hang another below it, and just increase the mass as you go. I don't really care, just as long as you get a good range of data. Oh, and one last thing. Like, for instance, this mass right here says 1 kilogram. That's cool. We want the mass to be in kilograms. We want to find the relationship of gravitational force in newtons, because that's the force of, or that's the unit of force, versus mass, which needs to be in kilograms. And so that one says 1 kilogram. You don't have to do anything with that. But this one says 500 grams. There we go. So that says 500 grams. That's not in kilograms. So you need to change it to kilograms. Move the decimal place over 3 places. So 500 grams is 0.5 kilograms. 1 kilogram, 500 grams is half of 1 kilogram. So that's why it's 0.5 kilograms. Whoa! And then we have this 200 gram. In kilograms, it's 0.2 kilograms. Okay. I'm not going to do any more converting for you. You can do it yourself. All right, so I think that's it. I hope this video was helpful. You should be able to get this lab done, no problem, in the amount of time you have in class today. The data collection probably get done in 5-10 minutes. The lab report is the easiest you'll write, just like any other lab report. Follow the physics lab checklist. And yeah, that would be it for now. All right, check you later, dude.